Swinburne University of Technology.
In this video we are going to look at how to do a one-way analysis of variance in R. We're going to have some dummy data, so we're going to look at some fake data of heights of boys and girls and aliens. I've drawn all of them out of a random normal distributions. They all have the same standard deviation, so I've cheated a little bit. I know that my quality of variance will be fine. And we've got means of 128, 130, and 75. So we know what is probably going to happen when we run our analysis of variance, but the point of this is to see how we do it. So I've made a vector, I've got all the heights in there together, boys and girls and aliens, and then I've used my rep command to generate strings, so 50 boys, 50 girls, 50 aliens, and factor is what turns it into a categorical variable. So we can have a box plot, and we can have a look at what these look like in a box plot. And so we can see there's the aliens, and there's the boys, and there's the girls. So it's kind of what we would expect to see. Okay, so there's actually two different ways we can go about creating our ANOVA. So one is to use the AOV function, and so heights is what we're measuring, and we are comparing it across the different types of boys and girls and aliens. So AOV obviously stands for analysis of variance, and I've just assigned it to an object called myANOVA. And when I type in summary function, whenever we've made some sort of model, summary is normally going to give us some tables with some useful stuff. So we can go summary, and then we can go myANOVA, and we can see that it's just given us basic ANOVA with a really small p-value, saying that indeed there is type is significant. So from here, what we would need to do is to determine where the differences are, to do some sort of multiple comparison. So for instance, we might do a Tukey honestly significant difference set of multiple comparisons. Pretty much any of the standard multiple comparisons are built into R, and we just pass it our AOV object, and we can see that it does our comparison. So boy versus alien, you can see significant. Girl versus alien, significant. Boy compared to girl, no significant difference. So it's given us mean difference, confidence interval for the difference, and p-value. So that's one way that we can go about doing our analysis of variance. The other way that we can do it is we can use the LM function. So the LM function is a generic linear model, and so we're just going to assign it. I'm just going to call it my LM ANOVA. So we're using the LM function, and we're still having all heights as a function of type. And this time, if we want to look at our ANOVA, instead of typing summary, we actually use a function called ANOVA. And we can see that reproduced our analysis variance table just like what we had up here, and we can see that type is significant. So the distinction here is I've had to do this because when we run a linear model, this is just treating what I've asked for, all heights as a function of type, just as a generic linear model. So it's going to build it up as a as an intercept plus a plus an effect for type. So if we type in summary, then what it's going to give us is a slightly different looking table. And when we get on to doing linear regression, all of our linear regression also uses the LM function. So using summary on my LM object is going to give me something that looks more like a regression table rather than an ANOVA table. So you can see I ran that, it's given me a summary of the residuals, and then it's given me a breakdown, so it's given me the intercept, and then it's given me the means for boy and for girl. but not for alien because it's used alien as the base category. So what it's done is it's set up dummy variables where we're comparing boy and girl back to alien. So boys are on average 52 centimeters taller than aliens, and girls on average 55 centimeters taller than aliens, and aliens on average 75 centimeters because they are the intercept. So what it's done is it's still done an ANOVA, but this output has treated it more like a regression. We can see we've got our adjusted R squared and our F-stat and things down here. So either way does give us the same information. Really, it depends how we want to see it presented. If we want to go with the more traditional analysis of variance style, then using the AOV summary gives me my analysis of variance table, and then I can do my multiple comparisons. If we kind of like the regression style, then ANOVA on my LM object still gives me my ANOVA table, just like what I'd seen before. But summary will give me kind of a much more regression style output. So here is my base mean, and then here is the addition for my dummy variables for boy and girl versus alien. So whichever way you use these functions, you're going to come out with the same answers, just slightly different looking output. If you're not sure about kind of what I'm talking about with this idea of the analysis of variance and building it up with dummy variables, I would definitely use some of the references in the notes to look at just that background to what an ANOVA is.
This has been a Swinburne production.